Ladies and gentlemen, I want us in this video to assist each other as to how its current or EMF induced in a generator. Mind you, I said generator converts mechanical energy to what? To electrical energy. That's what I said. Then I said they operate under the principle of electromagnetic induction, or you can say it's what? It's Faraday's law. Thirdly, I said generators to determine the direction of the convectional current. We use what to call the flaming right-hand rule. Of which on the flaming right-hand rule, you've got the thumb pointing on the force, this finger pointing on the force on the direction of the magnetic field, and then this finger pointing in the direction of the current. Then now we said, with regards to the current it's gonna move into the page, or the current it's gonna move out of the page. Then now the thumb, it's either the thumb can point upwards, meaning the force it's pointing upwards, or the thumb can point way downwards, where the force is pointing, where it's pointing downwards. So this one, the direction of the magnetic field, it's always from the what? From the North Pole to the what? To the South Pole. For example, if we can just throw any coil, we are throwing on any coil inside the magnetic field. We're throwing the coil, and then we label the coil A, B, of course, C, D. So we can use the flaming right-hand rule to determine the direction of the current on the side of the coil, which is labeled what? AB. The first thing that you need to pay attention to is the direction of the direction of the magnetic field. There you can see. So the direction of the magnetic field, it is from what? From the North Pole to the what? To the South Pole. And then after that, you can see I'm on the side AB of the coil. So from there, you can see that this is what is going to happen. So the force is pointing where? The force is pointing upwards, and then the current, you can say, into. That's the direction of the what? The direction of the current, meaning the current will be moving from A to what? To B of the what? Of the coil. And then you can see the direction of the magnetic field, which is from the what? From the North Pole to the what? To the South Pole. But now if I can go to the side of the coil, which is labeled what? Which is labeled CD, it's gonna be a different case in this. Mind you, the direction of the magnetic field mustn't change. So what is going to happen here on the other side of the coil? This is what is going to happen on the side CD. You can see the direction of the current has changed. So meaning the direction of the current is now moving away from the what? From the coil, out of the coil. And then the direction of the magnetic field still is maintained from the North Pole to the South Pole. And then the direction of the force, of course, it's what? It's now pointing where? It's now pointing downwards. On side AB, it was like this. So the current was moving into north to south, and then the force was pointing where? Was pointing upwards. So that's how you apply the flaming right-hand rule. Then now let's proceed. So we've got two poles, which is the North Pole as well as the what? As the South Pole on this green board. Then now inside between the North Pole and the South Pole, there are magnetic field lines. So the direction of the magnetic field is from the North Pole to the what? To the South Pole. Then I said, what is it that is happening? We take a coil. This is the coil. The coil is placed inside the what? Inside the magnetic field. That is what is happening. And then now, each side of, or each end of the coil, it's connected to what we call slip rings for an AC generator. But for a DC generator, each side of the coil, it is connected to what we call split rings. So then now here we are having slip rings. They are connected to each side of the coil. And then after that, we are having what we call carbon brushes. So each carbon brushes is connected to each slip rings. Then I've been explaining, saying the function of these carbon brushes, it is to collect the what? The AC current from the coil into the what? Into the external circuit. So meaning there's an external circuit connected to the what? To the carbon brushes. So the carbon brushes, they remain stationary. They don't rotate with the what? With the coil. As the coil rotates, the carbon brushes, they don't rotate. Then now what is it that is happening? Then we need to have what we call a rotation mechanism. Mind you, we need to produce this electricity. It is not there. So we need a rotation mechanism. So a rotation mechanism, it is that component that is used to in order for this coil to do what? To start it to rotate. So as we turn on the rotation mechanism, so the rotation mechanism will exert a force on the coil so that the coil can start to rotate inside the magnetic field. So as the coil rotate inside the magnetic field, then it is then that EMF is what? It's induced, and current it's also induced. But however, the position of the coil inside the magnetic field determine as to current or EMF, it's going to be induced or it's not going to be induced. For example, if the coil is positioned like this, horizontally positioned, mind you, bear in mind we've got the north pole as well as the south pole. If we position the coil like this inside the magnetic field, so what is it that is going to happen? For EMF to be induced, there need to be a change in the magnetic flux. Right. Once there's a change in the magnetic flux, then EMF will be what? Will be induced. So if the coil is positioned like this, we want to check as to is the change in the magnetic flux going to occur or not. So when we're talking of the change in the magnetic flux, it is produced at the point where the magnetic field lines are cutting through the what? Through the coil. Once the magnetic field lines cut through the coil, then a change in magnetic flux is what? Is produced. Once a change in magnetic flux is produced, automatically EMF will be what? Will be induced. So we can see if it's positioned like this, that a maximum number of magnetic flux as they are moving from the north pole to the south pole, a maximum number of magnetic field lines, they are going to cut it through the what? Through the coil. As they cut through the coil, then automatically EMF, there will be a change in the what? In the magnetic flux. Once there's a change in the magnetic flux, then automatically EMF is what? It's induced. But however, if we change the position of the coil to be positioned like this, we can see that a maximum number of magnetic field lines, they will just go through the coil without even touching the coil. You see, they will just penetrate through the coil. So there won't be any change in the what? In the magnetic flux, because it can only occur once the magnetic field lines touches the coil. So the maximum number of magnetic field lines, they will just go through the coil. As they go through the coil, therefore there won't be any change in the what? In the magnetic flux. Once there's no change in the magnetic flux, automatically no EMF will be what? Will be induced. No current will be induced. Meaning the magnetic flux, it is in its minimum where it is equals to 0. Once the change in magnetic flux is 0, automatically it's equals to the what? It's equals to the EMF induced. So automatically the EMF induced will also be equals to 0. Thank you for watching. Please follow me for more.